In this lesson, we're going to use our knowledge of quadratic relations of standard and factored forms of the quadratic equation and our algebraic skills to go between the two forms to solve some word problems. So as with a lot of word problems, it can be helpful to draw a diagram. We don't have to graph our quadratic relation, but a quick diagram can help us to represent the situation and see different parts of the relationship. So let's take a look at a few examples here. In our first one, we have a physics student that takes a potato cannon, shoots it into an empty field. He shoots the cannon at 0 seconds. So on our graph, that would be over here at 0 seconds. And it hits the ground again at 8 seconds. So because it's a quadratic relation, we know that we have the parabola shape in between there. And it tells us that A is negative 0.5. So A is the variable that is found in both factored and standard forms of the equation. So the first question we're asked is to write factored form for the equation of the potato's journey. So factored form, if you recall, y equals A times x minus r times x minus s, where r and s are the zeros. So A we're given in the question, it is negative 0.5. R, we can see from our diagram here, our first zero is at 0 and our second zero is at 8. So we'll just plug those in then. So we have negative 0.5 times x subtract 0, which because I'm subtracting 0, it's not going to change anything, so I don't have to write it. And because I just have x, I actually don't need the bracket either. And then the second 0 is x subtract 8. So there is factored form of the equation. So this models the path of that potato. Next question, we're asked to convert to standard form. So I'm going to multiply through. Now normally I would multiply through my two binomials, but because in my one binomial I have an x minus 0, I don't have a second term to multiply through. If I had that 0, multiplying everything by 0 would make it 0, which I don't need to have. So I can actually just take the negative 0.5x and multiply that through that set of brackets. So I have negative 0.5x squared plus 4x. So there is standard form for the equation. And question C says, if the vertex of the potato's journey is 4, 8, what does each number represent? So what does the 4 represent and what does the 8 represent? So we can see here 0 and 8. The halfway point there is 4. And remember that our axis of symmetry is halfway between any 2 points that have the same y value. So this is 0, 0, and this is 8, 0, so they both have 0 as their y value. So that means my axis of symmetry is exactly halfway in between at x equals 4. And the axis of symmetry goes through the vertex, which is either a minimum or a maximum. Because this one has a negative a and opens down, in this case our vertex is a maximum. So the 4 is on our x value, and x-axis, and that was our time. So we had 0 seconds and 8 seconds. So 4 is the time when the potato is at its maximum height. Now we know that 0 and 8 are in seconds, so that 4 is 4 seconds. And the 8, that is the maximum height that is reached by the potato. Now it doesn't mention anywhere what units that height is in, so anytime we don't know units, we will just write the word units. So 8 units high, that could be feet, it could be meters, or something else we don't really know. So if we want to find the vertex over here, they gave us the vertex, but that x coordinate of it, we could have found by finding the halfway point between our two zeros, the 0 and the 8. So if we find the halfway distance, or the distance halfway between the zeros, and then we can take that and substitute that into the equation. So for example, if I wanted to solve for my y value, for my vertex, I can sub in the x value, times, oh, sorry, missing a plus here. So plus 4 times x, there we go. So 4 squared is 16, half of 16 is 8, and this one's negative, and then 4 times 4 is 16, negative 8 plus 16 is equal to 8. So although we were given the vertex here, we can actually figure that out by looking at our zeros, finding that halfway point. That gives us the x coordinate, and then we can substitute the x coordinate into either of our equations. So this just goes over that. How do we find the midpoint or the halfway point, our axis of symmetry essentially, or the x coordinate of our vertex? So we can take our zeros and add them together and then divide the result by 2. So that gives us the x coordinate of our vertex. Now just remember that r and s have opposite signs as they do inside the bracket. So recall that the factored form of the equation is x subtract whatever r is, x subtract s. So when an r and s are positive values, we're going to have x minus a number. And when they're negative values, we would have x subtracting a negative number, which then would simplify to x plus a number. So because of that, whatever sign we see in our brackets, our r and s have the opposite sign. So let's take a look at a few questions here. So our midpoint, our r is a positive 2 and s is a positive 6. It doesn't matter which one is r and which one is s. We just typically go in order. So the first one's r, the second one is s. So to solve for the x coordinate of the vertex, I'm going to take those two and add them together and then divide by 2. 2 plus 6 is 8. 8 divided by 2 is equal to 4. Do another one here. So r this time is plus 1, so it's a negative 1. And s is plus 9, so it's a negative 9. So the x coordinate of my vertex, negative 1 plus negative 9, divide by 2. Negative 1 plus negative 9 is negative 10. Divide that by 2, and it's negative 5. In our next one, plus 4, so negative 4 is our r value, and s is a positive 2. So the x coordinate of the vertex for this relationship, negative 4 plus 2, divided by 2. Negative 4 plus 2 is equal to negative 2, and then divide that by 2, negative 1. And in our last one, r is equal to 14, s is equal to negative 2. So the x coordinate of our vertex is 14 plus negative 2, divided by 2. 14 minus 2 is 12, divided by 2 is 6. So for each of these, that gives us our axis of symmetry. So we have x equals 4 for this relationship, x equals negative 5 for this one, and so on. And then we can also take that coordinate, substitute it into that quadratic equation we have for this particular relation, and then solve for the y coordinate of the vertex. Okay, let's look at a couple more examples here. So a rock star stands on stage. So we're going to have time as our x-axis. And we have a stage here where our rock star is standing. And he kicks a water bottle, so it's going to go from the stage here and hit the ground. So this is at time equals 0. And we can see the relationship here is negative 1/3 times x plus 3 times x minus 9. So this tells us our zeros. Now this is the one that is the positive value. So this is at 9. So 9 seconds then is when the bottle was on the ground. Now this we can pretend goes backwards to that point, and that's going to be at -3. So write standard form for the equation. So this is factored form. That helped us find our zeros when the bottle reaches the ground and when it would have been on the ground if it had been kicked from back here. So what we will do is multiply through. So y equals -1/3 times x squared minus 9x plus 3x and minus 27. And then we will simplify, we'll collect our like terms. So we have x squared minus 6x minus 27, and now I'm going to multiply that -1/3 through by each of these. So we have a -1/3x squared plus 2x and plus 9. So there is standard form for this relationship. Now this, the c value, tells us our y-intercept. So in this case, that is going to be the height of the stage, and that is our next question. What is the height of the stage that the rock star stands on? So ax squared plus bx plus c, c is our y-intercept, so that's at time equals 0, and in this case that's the height of the stage. Now we don't have any information on units, so once again we're going to just use the word units. So it is 9 units high, might be feet, might be meters, we don't know, or something else. Next question, when does the water bottle reach its maximum height? So when, that's a time, so I need to know this x value. And so this is where we can find the x coordinate of our vertex by taking our two zeros, so -3 plus 9 and dividing by 2. -3 plus 9 is 6, divided by 2 is 3. So the bottle reaches its maximum height at 3 seconds. Next question is, what is the maximum height? So now that we know that the x coordinate is 3, we can pick either of our two equations and plug in that x equals 3 to solve for the maximum height that the bottle reaches. So we have -1/3 times x plus 3 times x minus 9. So -1/3 times x, so we're using this x here, plus 3 times x minus 9. So 3 plus 3 is 6, 3 minus 9 is -6, so I have a negative times a negative, so my final answer will be positive. 6 times 6 is equal to 36, and divide that by 3, that is equal to 12. So the maximum height of the bottle is 12 units. All right, let's do one last question together here. So a golfer drives her golf ball towards the fairway. She hits the ball at 0 seconds, and the ball lands after 12 seconds. So she hits the ball here, goes up, and lands. So she hits the ball at 0 seconds, it lands 12 seconds later. And we know that our A is equal to -0.25. So we're going to write factored form. We have our two zeros and we have our A value. So y equals A, that's -0.25, times x minus r. So our first 0 is 0. Now remember, x subtract 0 is just x, and that means I actually don't need that bracket. So there's my first one, x minus 0. And my second one is x subtract 12. So there is factored form of the equation to show the golf ball's pathway. Next question is to convert to standard form, so I'm going to multiply through. Once again, because I don't have x plus or minus a number here, I can just take this 0.25x and multiply that through. So y is equal to negative 0.25x squared plus 3x. When does the golf ball reach its maximum height? So when, this is a time, so our maximum height is our vertex. We're going to want to figure that out. But for now, we just need the x coordinate of that, which is the axis of symmetry, or the halfway point between our two zeros. So that happens when we add our two zeros and divide by 2. So 0 plus 12 is 12, divided by 2 is 6. So the golf ball reaches its max height at 6 seconds. Okay, and our last question, what is the maximum height? So this is where we're going to take this 6 and we're going to substitute it into one of those two equations. So y equals negative 0.25 times 6 times 6 minus 12. So 6 minus 12 is negative 6. So we have two negatives, so that's going to become a positive. 6 times 6 is 36, and times 0.25 is equal to 9. So therefore, the max height of the ball is 9 units. So once again, we're not given any information about units. So those are 3 examples that go through how we can use our knowledge of quadratic relations, of the parabola, the zeros, axis of symmetry, our vertex, standard and factored forms, and the pieces of information that they give us about a parabola, how to convert between those two, and then answer various questions with word problems.